Hi friends, today I am giving a lecture on example problem on how to solve non-linear or non-homogeneous recurrence relations. In the previous videos, we are already solved 7 example problems. So this is a different problem when we are compared to 7 example problems. Okay, now in this video we have to solve one different problem on how to solve non-linear or non-homogeneous recurrence relation. Okay, solve the following recurrence relation: a suffix n plus 2 plus 3 into a suffix n plus 1 plus 2 into a suffix n is equal to 3 power n for n greater than or equal to 0 with a naught is equal to 1 and a1 is equal to 1. Here 3 of n here is nothing but f of n. Whenever f of n value on the right hand side of the given recurrence relation is not equal to 0, that means 3 power n is not equal to 0, hence we can say that this recurrence relation is a non-homogeneous or a non-linear recurrence relation. Okay, so how we are solving that non-linear or a non-homogeneous recurrence relation? Okay, so this is the given recurrence relation, so this can be treated as equation 1. Now the general solution is a suffix n is equal to a suffix n power h plus a suffix n power p. So this is equation 2, where a suffix n power h is the solution of the homogeneous recurrence relation when f of n value is equal to 0. Okay. Next, a suffix n power p is the solution of the particular solution when f of n value is not equal to 0. When we are combining these two sub-solutions, then we are getting the final solution to a given problem. First, we have to find out this solution a suffix n power h. So now to obtain a suffix n power h, comma, put f of n is equal to 0 in equation 1. So this is the equation, this is the f of n value. Substitute f of n value is equal to 0 in the place of 3 power n. So that is what we are getting: a suffix n plus 2 plus 3 into a suffix n plus 1 plus 2 into a suffix n. Here we are substituting value 0 in the place of f of n, that is a 3 power n. Okay. Now this is now it becomes a homogeneous recurrence relation, but it is not in standard order. Standard order is a suffix n, a suffix n minus 1, a suffix n minus 2. Okay, to put this equation in standard order, okay, substitute n is equal to n minus 2 in the above equation. Okay, after substituting n is equal to n minus 2 in this equation, it becomes n is equal to n minus 2 plus 2. In the place of n, we are substituting n minus 2 plus 3 into a suffix n minus 2 plus 1 plus 2 into a suffix n minus 2. Okay, in this equation, substitute n is equal to n minus 2. Now what is the recurrence relation we are getting? So minus 2 plus 2 cancel, then we are getting a suffix n plus 3 into minus 2 plus 1 means a suffix n minus 1 plus 2 into a suffix n minus 2 is equal to 0. Okay, after substituting n is equal to n minus 2 in this equation, Now we are getting this is the equation. It is in the second order recurrence relation because nth term, n minus 1 term and n minus 2 terms are there. So it is the second order recurrence relation. Second order homogeneous. Second order homogeneous recurrence relation. Okay. For that second order homogeneous recurrence relation, okay, the characteristic equation is, so what is the characteristic equation for second order homogeneous recurrence relation is, so Cn into k square plus Cn minus 1 into k plus Cn minus 2 is equal to 0. Okay. So here a suffix n coefficient is C suffix n. A suffix n minus 1 coefficient is 3. Here C suffix n minus 1. A suffix n minus 2 coefficient is 2. Here A suffix n minus 2 coefficient is C suffix n minus 2. Okay. Now comparing this equation with this equation, so now C suffix n is equal to 1. So that is A suffix n coefficient is C suffix n. Here A suffix n value is nothing but k square. So k square coefficient is nothing but C suffix n. Here k square is nothing but A suffix n. A suffix n coefficient is 1. Therefore C suffix n is equal to 1. Next one, k coefficient is C suffix n minus 1. Here k is nothing but A suffix n minus 1. Its coefficient is 3. So now we are comparing this equation with this equation. Then C suffix n minus 1 is equal to 3. Next one, A suffix n minus 2 coefficient is 2. Here C suffix n minus 2 coefficient is 1. So therefore C suffix n minus 2 value is equal to 2. Okay. This equation is compared with this equation. So Cn is equal to 1. Cn minus 1 value is equal to 3. Cn minus 2 value is equal to 2. So after substituting this value in that equation, so after substituting Cn value and Cn minus 1 value, after substituting Cn comma Cn minus 1 comma Cn minus 2 values, then what we are getting, so Cn is equal to 1. That means 1 into k square. Next one, Cn minus 1, that is a 3. So 3 into k. Next Cn minus 2 is 2, that is 2 is equal to 0. So that is k square plus 3k plus 2 is equal to 0. Okay. So here k square coefficient is 1. 2 into 1, that is equal to 2. So then 2 can be written as 1k plus 2k plus 2 is equal to 0. K is common, then we are getting k plus 1. Here 2 is common, then we are getting k plus 1 is equal to 0. Now we are getting k plus 1 and k plus 2 is equal to 0. Now we are getting k is equal to minus 1 and k is equal to minus 2. Okay, so therefore k1 is equal to minus 1 and k2 is equal to minus 2. Okay, here the two roots are real values and distinct values. Okay, so both roots k1 and k2 are real and distinct. Okay, so whenever both the roots are real and distinct, the general solution is okay, case 1, Case 1 is a suffix n is equal to a into k1 power n plus b into k2 power n. So here a into, what is k1 value? K1 value is minus 1. Minus 1 power n plus b into, what is k2 value? Minus 2 power n. So this is a suffix n power h. So a suffix n power h. So solution is this one. So a into minus 1 power n plus b into minus 2 power n. So now this is equation 3. Okay. So once we are getting a suffix n power h value, so this is the solution. Now we are solving this one, a suffix n power p. Okay. Next one, to obtain a suffix n power p, put f of n is equal to 3 power n. So this is the given recurrence relation. On the right hand side, that is f of n value is equal to 3 power n, we are substituted. Okay, for this equation, we have to find out the particular solution. So now observe this, here f of n is equal to alpha into b power n. F of n is equal to alpha into b power n. Here alpha is a constant. Okay. B is nothing but root value. Here b value is equal to 3. Okay. So once we are observing that alpha is a constant and b value is equal to 3. Okay, now we have to observe the left hand side homogeneous recurrence relation roots. Left hand side homogeneous recurrence relation roots are minus 1 and minus 2. Here this part contains the root value minus 1 and minus 2. But here b value is 3, alpha into b power n. So b is equal to 3. So now b is one of the root or not for the given recurrence relation on the left hand side. Here b value is equal to 3, but b is not occurred among the two roots. Hence we can say that b is not a root of the characteristic equation on the left hand side of the given recurrence relation 1. So that now we go for according to the case 3. So here f of n is equal to alpha into b power n, where alpha is a constant. Alpha is a constant and b value is equal to 3. B value is equal to 3 is not a root of the characteristic equation of equation 1. Okay, here f of n is in the form of alpha into b power n, where alpha is a constant. So here alpha value is constant, that is 1, and b power n is compared with the 3 power n, b value is equal to 3. So whenever b value is equal to 3, we have to observe the given characteristic equation on the left hand side. The two roots are minus 1 and minus 2. So that b value is equal to 3. It is not there among the two roots because it is minus 1 and minus 2. So b value is not occurred in the roots of the characteristic equation on the left hand side of equation 1. So hence we go for case 3. So in the case of case 3, so the solution is so a suffix n power p is equal to a naught into b power n. A naught into b power n. So a naught is a naught into b value. B value is equal to 3. So a naught into 3 power n. So this is a suffix n power p. Now this is equation 4. So this equation 4 can be substituted in equation 1. Okay. So then we are getting a naught value. So for getting a naught value, equation 4 is substituted in equation 1. For getting a naught value, comma, substitute equation 4 in equation 1. Okay. So in equation 1, it is like in equation 1. So this is a suffix n value. So a suffix n plus 2, what is getting? A suffix n is equal to a naught into 3 power n. A suffix n plus 2 is equal to a naught into 3 power n plus 2. So in this one, a suffix n plus 2 is equal to a naught into 3 power n plus 2. Because n is equal to n plus 2, substitute in the place of n plus 2 we are substituting. So according to that, here a suffix n plus 2 is equal to a naught into 3 power n plus 2. Okay. Now a suffix n plus 1. So that is equal to a naught into 3 power n plus 1. Okay. So now these two values are substituted in equation 1. Here a suffix n plus 2, that is nothing but a naught into 3 power n plus 2. Next, plus 3 into a suffix n plus 1. So this value, a naught into 3 power n plus 1. Okay. Plus 2 into a suffix n. A suffix n value is this one. Here I am writing a suffix n is equal to a naught into 3 power n. So a naught into 3 power n. So that is equal to, here what is that? 3 power n. Okay. So now 3 power n plus 2 can be written as 3 power n into 3 power 2. So a naught into, so 3 power n into 3 power 2 plus 3 into a naught into 3 power n into 3 plus 2 into a naught into 3 power n, that is equal to 3 power n. Okay. Now we have to separate a naught into 3 power n. A naught into 3 power n we have to common. So a naught into 3 power n common, then we are getting 3 square plus, so a naught into 3 power n. So after common, then we are getting 3 into 3. 3 into 3 plus a naught into 3 power n common, then we are getting 2. So that is equal to 3 power n. So a naught into 3 power n, 3 square 9, 3 into 3 9 plus 2, that is equal to 3 power n. So here 3 power n cancel. So that is a naught into 9 plus 2, that is 20. So that is equal to 1. After cancel it is 1. So a naught is equal to 1 by 20. A naught is equal to 1 by 20. So now a naught value can be substituted in equation 4. Okay. So a naught value substituted in equation 4. In equation 4. After substituting a naught value in equation 4, then we are getting a suffix n power p is equal to, so a naught value is 1 by 20. 1 by 20 into 3 power n. So this is equation 5. Okay, this is the solution of a suffix n power p, that is particular solution. Okay, here a naught value we do not know. After finding out a naught value, then whatever the particular solution we are getting, that is the final particular solution. So now here a suffix n power h we are getting, a suffix n power p we are getting, then these two values are substituted in equation 2. Okay. Now after substituting equation 3 and equation 5 in equation 2, this is equation 2. Okay, so in this equation we have to substitute a suffix n power h, that is equation 3, a suffix n power p, that is equation 5. Once we are substituting these two equations 3 and 5 in equation 2, then we are getting the final equation. So this is equation 6. Okay, this is the final solution. In the given problem, the initial conditions. Now take the initial conditions. A0 is equal to 0, A1 is equal to 1 in the given problem. So put n is equal to 0 in equation 6. Then we are getting A0, n is equal to 0 means put n is equal to 0 in equation 6. A0 is equal to A into minus 1 power 0 plus b into minus 2 power 0 plus 1 by 20 into 3 power 0. Okay, so what is A0 value? That is 0. 0 is equal to anything power 0 is nothing but 1. So A into 1 plus b into 1 plus 3 power 0 is nothing but 1, that is 1 by 20. So a plus b plus 1 by 20 is equal to 0. Therefore, a plus b is equal to minus 1 by 20. Okay, so this is equation 7. Now here put n is equal to 1 in equation 6. So n is equal to 1, that is a1 is equal to a into minus 1 power 1 plus b into minus 2 power 1 plus 1 by 20 into 3 power 1. What is a1 value? That is 1. 1 is equal to minus 1 power 1 is nothing but minus 1. Minus a, minus 1 into a, minus a, minus 2 power 1, that is minus 2, minus 2 into b, minus 2b, plus 3 power 1 is 3, 3 into 1 by 20 is 3 by 20. Okay, now minus a minus 2b is equal to 1 minus 3 by 20. So here 3 power 1 is 3. So 1 minus 3 by 20. So that is equal to 17 by 20. Okay, so this is equation 8. Okay, solve equation 7 and 8. Solve 7 and 8 equations. So here a plus b is equal to minus 1 by 20, minus a minus 2b is equal to 17 by 20. Okay, so here minus a plus a cancel. So minus 2b plus b minus b is equal to minus 1 by 20 plus 17 by 20. So minus b is equal to, so 20 LCM here minus 1 plus 17, that is 16 by 20. So that is equal to 4 by 5. So now therefore b value is equal to minus 4 by 5. Okay, so b value can be substituted in equation 7. B value is substituted in equation 7. So a plus b is equal to minus 1 by 20. That implies a minus 4 by 5 is equal to minus 1 by 20. So a is equal to minus 1 by 20 plus 4 by 5. So take LCM, that is 20. 20 into 1 minus 1, 5 into 4. 5 into 4, 4 plus 4 into 4, that is 16. So that is equal to 15 by 20. So a value is 15 by 20. So now these two values, a and b values, are substituted in equation 6. So a and b values substituted in equation 6. Substituted in equation 6. So here what we are getting final? A suffix n, this is equation 6. A value is 15 by 20. 15 by 20 into minus 1 power n plus b value. B value is minus 4 by 5 into minus 2 power n plus 1 by 20 into 3 power n. So this is the final answer. Okay. So now we are checking whether it is correct or not. Substitute n is equal to 0 in this equation. So n is equal to 0 means this is 1, 15 by 20. Here n is equal to 0 means minus 4 by 50. Here 3 power 0 means that is 1 into 20. So 15 by 20 minus 4 by 15 plus 1 by 20. So here then we are getting A0. A0 is equal to 0. Next one, A1, that is n value 1. So here 1 means minus 1 power 1 minus 1. Minus 1 and means minus 15 by 20. Here minus 4 by 5 into minus 2, that is 8 by 5 plus 3 by 20. Then we are getting n is equal to A1 is equal to 1. So in this way we have to solve the given problem. So thank you. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa Rao. Thank you.